Hi, hello everyone. Hope you have a good first day. Actually, it's already the weekend in Berlin. So actually, I would like to welcome you for our session again on Thursday. So we will talk today about solid principles and how to refactor code. I will welcome Simon a bit later. I would just like to do like some kind of introduction because now, especially at that time, we are very it's very special. So actually now we don't do live events until the lockdown is done in Berlin, but we want to do as much live events as we can to keep you busy, guys, to learn new things. That's actually the goal of the Facebook Developer Circle, and especially in Berlin, we want to focus more on that. So I'm trying to do events every Thursday evening. So today is about Solid, but the next weeks we don't have event planned. So please feel free to reach us with new topics. I would be happy to host you and promote the event. So yeah, so stop talking. Let's welcome now Shuman. I will add Shuman now. Hello.
Hey, hello, Rafael. How are you doing?
Very good. And you?
Yeah, I'm also doing good. I just started I would say, early weekend because tomorrow is a vacation here in Berlin. So yeah, it's a like pretty long weekend, and yeah, I'm
Yeah.
ready for the weekend.
Amazing. So thank you again for doing that event with us. That's really
Yeah.
great, and I think it's very useful for people to basically learn those principles. Just maybe a quick question, not spoiling too much about your presentation tonight.
Yeah.
Why you wanted to focus on that, on those principles?
Okay. The thing is that I like as a software engineer, we always like heard about lots of principles, architectural patterns, design patterns, and most of the cases it happens that like we go through it, we read articles or we get the theory, but sometimes it becomes like we could not understand it. Like from my experience, I can see that sometimes it becomes like that. I'm understanding the theoretical part or I know that why we need it or how to implement it, but when we try it in a real life project, I don't quite understand that how I can implement it there. And sometimes without knowing the theoretical part or why you are using it, we are actually implementing it in our code. So I was going through these principles, and my like in an application I was going through my code and was just exploring that whether how many principles I am like applying or whether it can be improved. And then I was going through again through all the principles, and I found out like it's pretty interesting that most of the times we found like when I go through the theoretical part, we find it like it's maybe like so complex, but later I found out that it's actually simple. The more you focus on your code and you organize this, you will see that actually these principles have been already applied without even like you notice. So I thought that it would be great to share my experience with others.
Yeah, that's great. Just like quick question about one user already.
Yeah.
So obviously those solid principles are not language focused, right? But today we won't use so PHP for the command. It's not PHP, right? It's what's the
Uh,
language are you using?
yeah, I'm using PHP,
Oh, okay, PHP is
the,
perfect.
Laravel framework, because I
Okay,
found like it's pretty easy to implement here or will be shown, but it's can be implemented in any language.
great, cool. So I think I will leave you the stage now. So I
Yeah.
will just put my microphone in mute and put your
Yeah.
presentation. Amazing.
Okay, thanks, Rafael. So I'll start from here. So as I already said that the main purpose of this presentation is that I have been like going through my one of my application which I have written earlier, and at that time I was only focusing to like release the application. And in most of the cases in software like startups or when we start working on a project, we don't care about like coding organization architecture or something. Most of the times we mainly focus on like just releasing or delivering the products. So here I'll show you that how using solid principles I try to refactor my codes, and how like these things can be actually implemented from the very beginning of your project, and in the long run it will make your code like clean, well maintained and organized. So yeah, I will continue. So first thing, that when I was most of the times, like when we work in a existing project or in a legacy code base, what happens is that there are lots of code base and there's lots of developers who has worked there, and when we start working on it, we don't know that actually what's going on there, and sometimes it's not actually that easy to go through someone else's code and find out actually what's happening. And it comes up that we are reading more codes than actually writing codes or implementing or designing a solution. So and why we when we working with legacy code, there's as I was saying, that there's lots of reading and exploring rather than only working on the solution or developing a feature. And it's time consuming because you have to go through the whole system, find it here and there what's happening, and sometimes for minor bug it takes lots of time because you have to understand that what's happening inside. And sometimes it's hard to understand because maybe the code were not like well organized or it was not maintained well. So in this so now I'll see that how solid can help us to achieve this goal. And the thing is that solid is an acronym. So first let's quickly go through that what is actually solid. So the solid term came from, it's an actually acronym, and it's a collection of couple of principles that Uncle Bob mentioned in one of his software architecture related book, and you'll find that later he just or reorganized this and made it into an acronym. So we can see that the solid stands for actually 5 principles, and if we go through the 5 principles, we'll see that there's S stands for single responsibility, O stands for open closed principle, and L stands for Liskov substitution principle. Another one is interface segregation, and another one is, last one is dependency inversion. So from a first glance, like all these theoretical term or these name seems very theoretical and very complex, that what is actually, we write code, we make systems, and what's actually these things means and how we can apply these things in our application. And what it gives us is that if we can properly utilize solid, it can give our it can make our code maintainable. It makes our code or I would say that the goal of implementing solid principles is that so that our code become easy to extend and modifiable, and whenever we extend it and we modify, the system doesn't break. As a result, the code will be more testable. And again, we write codes for our fellow colleagues and other engineers, so when they come back to work on the system, they will find the code base easy to read and understand. So here first we'll go through just a small definitions of these principles, and directly then I'll dive into the code and I'll show you that how actually this principle seems a bit tough, but it's actually pretty easy to implement when you are writing codes. So the first principle, single responsibility principle, it mentions that gather together the things that change for the same reasons. It means that your class will only be responsible for only one thing, and if it does something else, you should put it away from that class. And your class should have only one reason to change, that will actually eventually implement the single responsibility thing. So there will be only one reason to change that. And what I'll do is that I'll directly dive into the code base and I'll go through one principles one by one, and I'll show you that how we can actually implement these things in our code base. So first we'll go through that how single responsibility principle can be implemented in our code base. So I'll directly go into my code base of an existing application. So it's let's say it's just a simple application. There's only a couple of features implemented, and what it can does is that like most of the systems out there, user can register in this system, and there could be an admin, and the admin can also see the users list, and the admin can also create an user, and there could be a couple of other features that will go along the video. And the system can be like, it can be web interface from where an user can register, and admin can log in and register for an user. And there could be a REST API where user can any client can just request and use the REST API to register an user. And also the admin, maybe through another client mobile app or something else, they can also create an user. So let's see here, the main goal is that we'll create a user and the user will be saved in our database, but the interface is different. Like a user can be created like when someone comes to our website and they want to register and register as an user. So they can register as an user, and there could be time that from admin panel, user and admin can also create an user. And also there's a chance that these actions can be also done via an API. So let's go through our code where I have already written that how this code works or to register an user. And as like many simple applications around the web available, you can just register, and the basic code is that first we get data from the user, we do some validation on it, and if it goes well, we purchase the user to the database. And for web, if it goes well or it succeeds, we redirect back the user to the login page, or we redirect back to the user again to the registration page with a success or error message. And in case of API, it's the logic is same, but only the response is that here we are only returning the JSON response. And if I care about the admin user, here he also can create a user. So here you can see that we are doing one operations, but the code has been duplicated in 3 places. So the thing is that it's not like dry. I am repeating codes more than once. Second, it's not well maintainable, because if I want to change something here, I have to change back to in all 3 places. So it's a very bad code, because it doesn't follow the dry rules, like don't repeat yourself. You should not write a code more than once that does only one job. And here it does only creates the user. So how we can use like single responsibility principle to make this code better? So first let's talk about this auth controller and register method. So what is the main responsibility of this method? The main responsibility of this method is that it will take some data from the input, it will process it, and it will show or give us an output. So it doesn't have to think about that how to validate this data or how to purchase this user data to the database. So how we can make use of single responsibility principle to make this code better? So first thing is, we see that here's this validation part. It's not related completely related to this register method, so we can easily move this away into another place. And here for the code base, I am using Laravel framework, and in Laravel framework there's a HTTP folder and request folder where you can use a form request type of class where you can actually organize your validation rules. And here we can just move away this validation rules from here to here. Okay, so we get rid of this validation logic from this controller, because here this doesn't go with the controller. And just here we are taking a request object instead. Right now we'll pass this form request object create, which is an instance of create user request. And if I pull it there, it will automatically handle the validation. Laravel works that way. It makes use of the form request class, and it will automatically apply the validation rules. And if it succeeds, the method will be called. And otherwise, if the validation failed, it will automatically redirect back to the user, and the user will even not come to this method, and which actually respects the single responsibility principle, because when user the register method is called, we are only expecting that it will create the user to the database and show us an output. So the validation doesn't actually go with this method. So before actually trying to create the user, the validation should be done, and that's what exactly happening here. We have completely differentiated the or separated the validation part from this controller method to its separate like single responsible validation class. So we have now easily change the logic from here, and what happens is that we can easily now implement this class to other places where the validation was needed. So from auth controller to we can easily move to the user controller, and we can do the same thing here. And we can get rid of this code. See how it become easier for us to like reuse this code, and we can easily like implement these things to other places where we were using this validation. I just do in another places, but I think you can understand that what's happening here. And we can get rid of this. And the next thing is, let's come to this point now. We have taken care of the validation part. It's moved to another part. So single responsibilities has like listability has been applied here. And now we see that there's another thing that's happening here is we are trying to do a database operation directly from here, which actually again doesn't go with the responsibility of our controller method, because it should only expect a input and only show us an output. So we need to get rid of this and move it to another place where we can actually sensible for it to move. So instead of, and we also see that the same code is actually used everywhere. So the responsibility of persisting an user to a database, it should be done by a repository. So what we will do is we will create a I have actually already created a repository folder here, and here we have already created a user repository class. So I'll open this, and here I have just kept a blank create class, which will be used for actually creating or persisting the user to the user table on our database. So what we'll do is we'll move away this code from here to here. Okay, and first we can just return the user object from here, and we need to get the value from our use this object. We need to pass it to our repository so it can get the data and save it to the database. So let's just get the request object here. We can always type it to make sure that we are actually getting the request object or passing it, so that we like do not provide any other data type or any other instance apart from this request object. So here what we need to do is that we can just bring in the inject the user repository here, and we can call user repository create, and we can just pass the data here. And now you see that our code has become much more cleaner. Here you are only seeing one responsibility is going here. Here the user comes, it only according to the process, it only shows us a output or redirects back to the redirects the user to the process, or shows a error or redirects the user back. But if you see here, only the process is happening, and it has become much easier to organize your code and changes. So right now, if you want to change anything here, you can just do it here, and you will not need to change your code everywhere in your code base. So we can just reuse our code in every places where we need to create a user. And yeah, we need to inject the dependency user repository. So we'll do this for all the places where we need to create user. See? So by applying the single responsibilities principle, now our code has become, first of all, it's very easy to read and understand now. You just come to this form, that first form request handles this request that we are getting from the user, and it validates the data. So there's only one single source of truth here. You need to add anything to the validation, change any rules, you just do it here, and it gets automatically implemented in everywhere in your code. So there you don't have to write the codes more than once. Another thing, that the portion that has been responsible for storing the user to the database, we have by using user repository, we have just established that thing. Here we can easily put the logic here. If we do want to put any logic, we can do it here. Like we need to maybe encode or decrypt our password before entering it into the database. So we can easily do it here. And the controller, it doesn't need to know about anything, that how this data will be processed and what will be happening. It just needs to know that it expects a output, so it will get the output from here. And as it's returning the user object, we can just get the user object here, and if we want to use it somewhere, we can easily make use of it. So this is the beauty of single responsibility principle. And you can see that it's very easy. It's just reorganizing your codes and making sure that only one class does only one thing. For example, here create user request is only doing the validation thing. Repository is only responsible for the storing the user to the database, and the auth controller, the register method, the controller should be responsible for only getting the input and showing us the output. And that's what exactly happening here. So I think you have understood this principle, and you can see that it's very easy to implement, and it has already made your code very well maintained, easily readable. So let's focus on the second principle right now. And let's get back to my presentation, and we'll go through the second principle now. And second principle, it mentions that its name is open close principle, and from the name it may be a bit tough to understand what actually it means, but it's very easy to understand. It says that you should be able to extend the behavior of a system without having to modify that system. So what does it means is that you have developed an application or system, and if you need to extend any behavior or modify any behavior within the system or your application, you do not need to modify anything inside that system. So for example, I have made a like a user registration system, and here I need to maybe add some new logic there. So the system should be, or the code should be organized in a way that if I want to add a new logic into the system, it should be pluggable or should be doable outside of the core logic. We can't actually go inside of the logic every time and make some changes there, because if we do that, then these changes will have impact through all our system and it can break our code. So we'll see that how easily we can implement open close principles. So here that it mentions that the classes, modules, functions, and other things should be open for extension. So it means that it should be written in a way that if needed it can be extended or add new things from outside, but it should not be written in a way that if I need to do any modification, we will need to do it like from the inside. It should not be that way. And another thing is that to extend the functionality, we can only add new code instead of modifying the existing code. So we'll see right now in an example that how we can easily implement this feature in our code. And I really love this principle, because if you can really implement this feature, your like a whole system will be easily testable and easily extendable. So let's see. So let's get back to our application, and besides registering the user, here we can see that to in our system, let's say the user registers and they can have multiple like multiple level of subscription options in our system, and they can be a free user or they can be a subscribed users. So for that they have to pay the system to be a subscribed user. So what they have to do is they have to pay us. So here I have a simple pay endpoint, where if the user will send necessary data, for example, it's that the payment type, that how the user wants to pay us, and it will run the pay controller's pay method. So let's go back to I'll just clean up the methods, the files from here, and let's go back to the payment controller and let's see that how the current code is implemented here. So if you can see that currently the legacy code is implemented in a way that it comes here, it takes the request from the user, and what it does is according to the payment type that user have chosen, we try to process the payment request. So what it does is, if the user selects PayPal, we call the pay with PayPal method of payment service class. And if I go here, we'll see that there's 3 methods here, because we are providing the user options with 3 payment methods. One is PayPal, one is credit card, and the default is, let's say, wire transfer. In countries like Bangladesh or in some countries, PayPal or direct international credit card transaction is not the payment gateway provider are not available. So maybe we'll need to do a wire transfer. So the user can choose this. So the problem with this code you can see is that if you want to do any kind of changes, you will have to do it here. But my controller method, it should not be bind to these things here, because how the process will happen, it doesn't need to know that how these things will go. It will only need to know that I want to process this payment and I only want a response. But here you see the code is very much dependent here. Whatever changes you made here, you have to accordingly make the changes here, like credit card, or if you want to like make a new payment gateway, you have to change your existing code or make some changes here. So how we can get rid of this? Obviously we'll need to implement the open close principle. So let's do it. So how we can do it? First of all, let's focus on one thing, that let's come back to our payment service. So here we are doing the payment processing thing, and what it does is, like pay with PayPal does its own logic to process the payment with PayPal. Here credit card does the same processing logic that need to be done for the credit card, and here it is for the pay with wire transfer. The logic is different, but if you see that the like goal of the of these methods are all same. So why we should duplicate these things here? So instead, what we can do is that we can make use of the interface feature to apply the open close principle here. So let's do it here. So what we, instead of using this, what we'll do is first we'll create a payable interface. And what it will does tell us that whichever class implements this payable interface, it needs to implement this pay method. And for this, let's create a folder here, payment. I have already created it. And here we have like 3 different payment method. One is credit card payment, one is PayPal payment, and one is wire transfer payment. So as per like single responsibility principle, everything that one class does, it only should do that thing. It should not do any other thing. So here it was doing multiple things, like it was doing the payment thing with for PayPal, for credit card, and wire transfer. So let's get rid of these things and make this code more well organized. So I have created 3 class here. So for processing the credit card payment and separate the logic from here to its own class, and which automatically gets us to the single responsibility principle. And now let's see that how we can make this the implementing the open close principle. So what we can do is, we know that what this class will do, it will pay the user, it will be used for pay method for us. So we can easily make sure that this class implements the payable interface. And let's just load this interface here. app/contract/payable face. And when we implement these things, it will automatically tell us that we will need to implement the pay method here. So here we can take the pay method, and here it may be do the logic for the credit card, and same thing we can do for the our other payment methods. So it goes for maybe PayPal, and it goes for the wire transfer payment. So right now all our payment methods have its own class, and all the logics are separated into their own classes. And now let's see that how we can like refactor our payment service class in a way so that we don't need to think about that how these things are happening here. We don't need to handle that if it's PayPal, call this PayPal method. So let's get rid of these codes first. And here also just think that what we want to do here. So to get the response, we just want to know that we just want to let the payment service know that maybe just let's say initialize. And we only pass the payment type to this service, and we don't need to think about anything else that what's happening inside. We only let the payment service know that yes, the user wants to pay using this method, and everything inside payment service will handle. So let's create initialize method here, which obviously takes this string type parameter, and according to parameter, what it will do is, if we can easily just do a switch catch case block. So if it's a PayPal, then we just need to return an instance of PayPal payment. So, and if it's, let's say, credit card, I'll just fix the typo here. And if it's a credit card, it will just return the instance of credit card payment. And by default, we can say that if the user doesn't choose anything, we'll return the wire transfer payment. Okay, so here on the controller, we just need to initialize the payment service with our payment type, and then for getting the response, we can just call pay method here. Payment, and yeah, and we can just take the output here and pass it here. So here you see that from lots of dependent code from here, that in the beginning, all the logics to select the payment gateway and process the payment gateway data with the payment gateway, all the logics were here. But by implementing the both single responsibility principle and open close principle, we have achieved a very readable and testable code here. Because, and now right now, if you want to like create a or add a new, let's say you just want to add a new payment gateway, what you just need to do is that you just need to create a, maybe let's say, Braintree new class here. So again, before going through what we have seen on the principle, that your code should be open from the outside to extend, but it should be closed for modification. So here we want to add something new to the system. So here we cannot do any changes here inside into our logic. So we'll not actually do that. So it's already closed, but it should be open for expansion. So what we will do is, what we can do is that we can use a like just load another payment. So we just want to add a new payment gateway here. So what we just need to do is create a new class and make sure that it implements the payable interface. And we just need to load this and implement this pay method here, which will handle the logic for the Braintree gateway provider. And see, we have just added a new class, and in our payment service, we just need to let the class know that if it's Braintree, then load the Braintree class. So you don't need to do any changes here, and your system is easily extendable, and it will not like, it is not breaking your existing code here. So we have achieved the single using the single responsibility principle and using the open close principle, we have got a very well organized code here. Okay, I hope that this gives you an idea that how the open close principles can be implemented. And you have already seen we have already applied two principles from the solid principle, and already our code has become very well readable, well maintainable, and it has become very easy to understand your code. So let's go back to the third principle, and I would say it's a bit complex one. Like from the definition, it seems that it's a very complex one, but it's a very not it can sometimes it happens that we don't know that how to implement this in our application, and it is one of the most technical principles of solid principles. And most of the times when we develop or design an application, we don't know that how exactly we should implement this feature, but it does have some important consequences for designing object-oriented software if we cannot implement this principle. So for let's see in plain text that what this principle means. That it means that any derived class should be able to substitute its parent class. So simply it means that you have a parent class and you inherit a class from it, which is your subclass or derived class or child class. So if you are using this child class somewhere, so the substitution principle says that it should be substitutable or replaceable by the parent class, and it should not break anything. And for this, it actually seems a bit confusing here, but we'll see that how easily we can implement this thing by using the interface feature or the interface segregation principles. And another thing I want to mention during this implementation is that the solid principles, all those principles are actually connected with each other. There may be sometimes that you implement one principles and it automatically connects you with other principle, and all these things are connected. And sometimes you just don't need to implement these principles one by one. It's all connected, and if you can implement one or two principle proper way, you will see that all other principles have been automatically implemented. So let's go back to our code again. And actually we can easily achieve Liskov substitution principle by using interface and polymorphism feature. So let's say here we have made the payment, and right now we need to know the payment status from the vendors. And here if we come back to our payment service or the kind of payment we were using here, there were Braintree, which is a third-party provider, and like that there is PayPal and credit card. So all this requires third-party response from those gateways to let us know that yes, what's the status of this service, or what's the status of the payment. And there's also wire transfer payment, and you can understand that it's kind of a I would say a bit manual process, where maybe the user has sent the money to your bank account and the admin of the system, or you check back on your account that whether the money has been deposited or not, and then you maybe somewhere in your database you update the status that yes, this payment status is updated. So here I have created a simple route where if you request, it will show us that what is the status of this payment controller. And if I come back here, I see that here, for example, I have first implement or created an object form, PayPal payment status service. And what is does is it provides us the status of the PayPal payment status. And as I was saying that for PayPal payment, Braintree payment, and credit card payment, we need to like maybe communicate with the third party services, and if they authorize us, then we can get the status. So here what we are doing is that we were just create an object of this class. First we were authorizing, yes, PayPal should know that yes, we are authorized to get the status from them, and we get the status from them. And we can easily change from here if we want to get for Braintree, not sorry, not for Braintree, just do it for credit card payment status service. We can easily do this. So it's happening that if I come back here, we see that both these classes actually comes from payment status service, and it says us that all status service classes should implement at least get status method. So according to the Liskov substitute principle, if I try to change this class from credit card payment service and PayPal payment service to one of its derived class, like here payment status service is the original class. From there we have extended PayPal payment, credit card payment, and there's another wire transfer payment, right? And all these, as we have already mentioned, that all this class should implement get a status, and we are watching that yes, all these classes have extended or like implemented the get a status method. But if you can see that all this, though all this comes from this mother class, but here this class is a bit different. For both these two, we have an extra authorized method which does some extra checks with the payment gateway provider and shows us the result. But for wire transfer, we don't actually need this need to authorized or go to the third-party services, because we are handling this status inside our own system. So Liskov substitution principle says that if right now I change the class to wire transfer payment status service, it should be substitutable. That means that it should not break our current code. But if we see here that this code breaks actually, because here in the wire transfer payment status service, the authorized method is not there, and it violates the Liskov substitution principle, because we can't actually substitute the class here. So how we can solve this here? As I said, that by properly implementing interface to this class, we can easily solve this problem. So actually, the way we had done it for this payment service, we can do it here. So how? We'll need to create a contract, another interface which says that yes, there's a authorizable interface, and whichever class implements authorizable interface, you need to implement a authorize method. So instead of creating this class or extending this class from our payment status service, what we can do is, here we can do another thing is that okay, what we can easily do is that we extend, and for credit card payment service we say that it implements the authorizable interface. So we only know that if it's authorizable interface, then we need to implement this authorized method here, and we can do the same thing for PayPal payment status service. Instead of implements authorizable interface and implement this thing here. And here right now we will not need to where is our controller? Here. And here we can easily do is that credit card payment service, and it's available here. And just like payment service, we can maybe create another service, payment service. We can create payment status, change this class actually. This we make it a class just as payment class status service. And here what is it does is, or what we can do is that we don't need this class anymore. Wherever we need to use this, we can just directly use this feature. And here we don't need to do anything. We can just pass it here. And here it doesn't actually implement the authorizable feature, so we can get rid of that one. But on our get status, what we can do is that for credit card we can call this thing here, maybe this authorize it here. And for PayPal payment, we can do the authorized thing here, so that the user who will be working with this class or the third-party payment service provider, they know that if they implement this authorizable interface, they need to implement this method. And for wire transfer, we don't need to do anything. We just can use this thing. And from here right now, whether we change anything here, the class, our code doesn't break anymore. We can easily substitute the classes here. But by the time we are trying to implement this feature, as you have seen, we have already implemented another solid principle here. Actually, we have made use of the interface here, and it has helped us to like implement interface segregation principle. So let's go back to our presentation and see that what the fourth interface segregation principle says. It says that no client should be forced to depend on method it doesn't use. So what it means is that when we are using a client, it shouldn't like there could be many interface and contracts in our application, but any client or class only should force be depending on that method if it really uses it. If it doesn't uses the method, we don't need to implement the interface. And by implementing this or trying to implement this principle, what we'll get is that the interface will be divided into many small and specific interface instead of like we made a interface and we add more like many methods there. And this will also help us to like tailor interfaces to individual client interface, what we'll do in our next example. And changing one method in a class should not affect classes that don't depend on it. So let's see that how we can implement or see an example of this feature. Let's say that we have done the payment successfully, and right now let's come back to our auth controller thing again. Not here. Yeah, let's see. Let's go back to our user controller. And And let's say that whenever a user is created, we make it user a subscriber of our system, and whenever a user subscribes to our system, we need to send an notification to the user. So let's go back here, and let's say that when let's go back to the payment controller, and let's say when a user successfully has made the payment, we need to send a notification to the user, and to also make a user subscriber of our system. Let's say we have a entity in our system named subscriber, which actually is responsible to subscribe our user. Also they can unsubscribe, and to set the notification email for the subscription, we need to know the user notification email. So here, if I want to send the notification here, let's say we need to create a notification service, which actually have a just send class. So what it does is, let's just inject the notification service here. Let's sorry, it's notification service, and let's just name it notification service, and we need to send the notification. But to send the notification, maybe after the user has successfully completed the payment, we make a, I'll just use the dummy data, maybe create a subscriber with this user data, and maybe here we have a subscriber. Let's say we create from here. But in ideal cases, like I am violating the single responsibilities principle here, maybe I would do that in our payment service, or I will completely get rid of this code into another class. But we have already seen that how we can implement that here. Let's just keep the code here too for this example, and we need to pass the subscriber here. So the send method will know that yes, the subscriber is here, and here to send the data, maybe we get the subscriber get notify email, and we get the email to send the notification. But the problem here is that the subscriber model doesn't necessarily depends on this, because the model can be here, it is expecting only the subscriber class because it has the this method. But maybe in later we remove this notification email from here to another class. So at that time it will break, because let's say that instead of subscriber, maybe we have done another entity, let's say paid user, and they were moved to another entity paid user. But here it expects a subscriber object, instance of subscriber object. So our code has it's becoming bound to here, and it will break our code. So by using interface segregation, we can easily solve this problem. How? Let's see. We know that this notification service is to send a notification, it depends on this get notify email. It doesn't actually care about the subscriber model, what it has inside, or any other things. It only needs to know that the object here will be coming, it will need to implement get notify email. So for that, what we can do is we can create a new contract here. Let's say its name is notifiable interface, and it says that whoever wants to notify use the notifiable interface, it need to implement the get notifiable interface and need to implement this method. So what we can do is, instead of binding it to the subscriber, we can say that whichever object has the notifiable instance of notifiable interface, then it will be, because we know from here that whichever object comes here, if it implements the notifiable interface, they will definitely have the get notify email. So whatever changes is done outside of this class, it will not have any impact here. And how our code will change here? Here, if I come back to, let's say, our subscriber, we just need to make sure that our subscriber model implements notifiable interface, and it doesn't actually care what object you are passing here. Let's say it's changed here. Instead of subscriber, we move our user data to another entity, maybe user. And right now, if I go to the user, let's say that if I have only made the changes here and I don't need to make any changes here, what I need to do is that I need to let the user know that if you want to make it notifiable, you have to implement the notifiable interface here. And for that, you need to add the get notify email here. So here, the interface that you are using, it doesn't actually making any impact here. We can easily use that interface in any entity of our object, and we can just use this notification send service, and it doesn't actually have any impact inside here. So whatever object you pass here, it will, if it actually implements this notifiable interface, it will work on this. Okay, so that's what actually like interface segregation things. And interface segregation thing, another thing is if like from Laravel part, you can see that we have 3 separate interface, like implemented separate interfaces here. So the interface segregation means is that you make a small parts of this interfaces. Let's say here we have used notifiable interface, and here we have used notifiable interface. So as we have kept the interface simple and only a small for only the purpose it serves, so it has become much easier to use this with multiple entities. We can easily use it with subscriber, and here we have been also able to use this with user. But if it were into like maybe let's say authenticatable contract, then we would not be able to use it with subscriber. So we have to find out that how we can make separate interfaces and make it as simple and as small possible, so that we can easily reuse those interfaces for only the purpose it's need to be used for. And that's get us to the last principle, and it's quite easy actually, and we have already have like seen some examples of this dependency inversion principle. And what it says is that high level modules should not depend on low level modules, and both should depend on abstractions. So what it means is that never depend on anything concrete, only depend on abstractions, and able to change an implementation easily without altering the high level code. So let's see that how we can achieve this. Let's go back to our for a simple example here. Let's see that there's a user controller from where you can see the users list. So let's see here that to get the user list, so let's say our use case is that we want to get the user which have registered in our system within last day, maybe like yesterday. After yesterday till right now, whoever user has registered in our system, we want to get them. So right now, normally we would like write the code here, we would get the model here, and we would get the user here. But the problem here is that you can see that we don't need to know that from which storage model or how these users are coming here. But here the model is inserted here, and we are responsible to get the query or make the database query here, which is not the actually proper place to place here. So how we can get rid of these things and do dependency injection, dependency inversion to make this code better. So we'll get back to our user repository. We know that database operations should be done from the user repository. So we create a new method here. Let's say just make it into a new method. Let's say get users users from yesterday. Let's just say that it's a method, and we create it here. Okay, and what it will return us is that user where, and we put the logic here created. And before continuing the code, let's just say here the code we have here, for some reason our storage changes or the model changes or the logic changes, then actually everywhere we were using this code, we needed to come back to here and change the code here, because in our controller here the logic is implemented here. But as from the very beginning of our session, from the single responsibility principle, we have said that the controller method should only be responsible to get the request and show us the output. It should not know or have the logic here. That's why we are getting this out of this method and putting it here. So let's get it from here to here. And okay, we need to send the user model here. Okay, or we could actually don't need here. We can just make this more simpler. We can just construct and say that user repository always gets the user object for us, because maybe for some other operation we'll need the user object. So let's just get it here. So we can just call it here, and instead of putting the logic here, we can just, instead of getting the model here, we get the repository here only. And let's rename it, fix the PHP doc block, and we can just call it here. And what this will do is that right now you can see the logic is moved from here. So wherever we want to load the users from yesterday, we can use this repository, maybe in the index method or maybe somewhere else in our code base. And to make this thing more strict, we can say that user repository need to implement user repository interface, and inside this user repository interface we can say that yes, user repository interface, here we can see from the code base that user repository has been used to create a database and has been used to use like get users from yesterday. So from high level our code, like here the logic is in the higher level, and from here we can see is that we can create a user and we can get user from yesterday. So the principle says that we don't need to do anything here. Instead, we can let our low level code base know that yes, from the higher level we will need this method, and here it is get user from yesterday, and here user repository method will automatically know. Oh, okay, the signature here and here it should be same, so we can say that it should be a request. And it should, okay, let's see what's happening here. Declaration, okay. Oh, okay, we forgot to load the request namespace. Then it should work fine. So from here we can see is that if I go back to our dependency inversion principle, it says that they never depend on anything concrete, only depend on abstraction. So here you can see that user repository doesn't really like depending on what this it need to do from the higher level. Instead, it comes back to this repository and implements the things it needs, and then according to this repository, wherever you want to use, you can use these things. And if you need any other thing here, you can maybe just add another method here for your purpose, that what are the operations you need to do from your repository. So if I go through again, that never depend on anything concrete, only depend on abstractions. And another thing is that able to change an implementation easily without altering the high level code. So how we can implement that? Here we are getting the users from yesterday, that is our high level code. And to change a logic here, we don't need to actually change anything here or to create the here. Instead, we can easily come back here and we can change the logic here in the low level code. So as you can see that by using these principles, I have already made some very good improvement in our like in my current code base, and it has become like much easier to understand that what's actually happening in what classes. And if you want to like implement a new feature, like with the example we have seen, that if you want to implement a new payment method, you don't need to do anything. You can just easily follow the current implementation, and if you properly use use the interface, you can easily know how to implement that thing in your code base. So yeah, that's have been my session for today, where I tried to show you that how I can use these principles to make our code base easy, clean, and well maintainable. And as you can see that it's not actually very tough thing. There's not any complex logics or engineering things behind it. It's just how you plan your code base, how you know that how the system talks with like inside, and how things are connected with each other. And if you can just understand those things easily, you can easily like make use of solid principles in your code base. So yeah, Rafael, are you here? I'm almost done.
Yes, I'm here.
I
Yeah,
think
thank
it will
you.
be a bit
Sorry.
longer.
No, it's all good. No worries. I mean, I think it's great. I think so I don't know. Do you have anything else to show? I can just go back. Maybe your contacts. You didn't share your contacts. Amazing.
Okay. Yeah, just to finish the session, that I'm working as a software engineer at Seven Standards here in Berlin. I have moved here like last year May, and before that I was working in Dhaka, Bangladesh, and I'm working with PHP like for since 2010. and I am working with Laravel since 2014. And after moving here since last year, right now I am working with Symfony. Yeah, and here's my like a personal blog address and a Facebook page where I actually share my this kind of sessions, or I really love to like share my knowledge with others, because I found that the more I share knowledge with others, it becomes easier for me to learn new things and enrich my knowledge. Yeah, that's it.
Cool. Thank you very much. Actually, I was reading because actually we have Mikael on the live. Actually, is doing a lot of advice. Okay, I'll just like yeah, you can keep the contacts on the screen for now. Is doing a lot of advice and suggesting names and stuff like that. So actually, it's very nice.
Okay.
It's not very questions, but I think it's very interesting. Like the last comment, for example, is. These kind of examples are also good to reuse for the cases that we have classes that don't belong at the same bounded contexts.
Yeah.
For example, legacy code that may have not compatible, and then we can use adapters classes, for example. So yeah, no, that's very interesting. And actually, we saw like in a bit more than an hour how easy it can be to implement those things. So yeah, that's great. Actually, I'm trying to think about. So just one question. How, because you were saying basically you were learning those principles by reading blogs and doing stuff. What was the process there to learn those things? Because obviously it's very difficult. I mean, I read a lot also. It's very difficult to understand things. How did you manage to learn those things alone?
Okay, what I first try was to understand the each principle separately, and most of the times when we try to actually find resources on the internet, actually the major problem is that the examples we find on the internet, it talks about those principles separately, and each example is different. So it's not kind of a like one single application where you can see that how all these were implemented. So that was the challenging part, that I am understanding this example, but when I am watching resources for another principle, the context or the example is quite different. So it was very tough to actually find the relation between one another. So what I was doing is that to get more deep into the system, and from the example I was trying to understand that what actually I am trying to achieve here. Then I tried to achieve this in a single application one by one, and try to find out the correlation between all this. That like just the way I showed here, that in a single application actually we are trying to implement one principle, and it was helping me to automatically actually prepare for another principle.
Yeah, that's the good thing about those principles, is actually they are kind of interconnected. So actually it's very, when you do one principle, actually you kind of already implemented like another principle also.
Yeah.
Like especially like the interface segregation and stuff, it's always very easy actually. After that, it's just like more understanding and how it works. But yeah, that's very interesting. Yeah, I actually don't have necessarily a lot of questions actually. Maybe because you talk about service centers, can you just maybe mention what they are doing exactly?
Okay. So Seven Senders is, I would say, like they promote as the leading delivery platform in Europe. So what we do is that we help the e-commerce owners in Germany to deliver their products from Germany to other countries in Europe in an like efficient or like less like in a cost-effective way. So what we do is like we pick up the parcels from our clients in Germany, and then we use our own transportation network to deliver this product from Germany to nearby border areas of other European countries. And we have local partners in those countries, and they pick up the parcels from there and deliver it to the like customer. So as we are using our own transportation network and we have local partners in those countries, so it becomes like more cost effective rather than when you are using a single vendor like maybe DHL or other things.
Okay, interesting.
And I'm
And
working in the
yeah,
transportation network team. There we are responsible to develop the software which is being used to plan all this pickup, transport management, which route or lane the transport will use, from where we need to pick up the parcels, these things to schedule all this.
okay, nice.
Yeah.
And my last question maybe for tonight would be because so you moved to Berlin, but basically how you learn software engineering? Did you do some kind of coding schools, or how did you learn developing?
Okay, it was a pretty interesting journey for me. As I said, I have written my first PHP code in 2019, and when I first got mobile mobile, I started to browse websites, and from there I got got a to know that yes, for using programming language you can make websites. And then I got to know about PHP, and for at that time I used to make a small websites only for fun. And after that, in 2011, I started my graduation in computer science and engineering. And at that time, I got to know about basic software engineering principles, loops, variables, these things. And I really liked it. After 2 or 3 years, I found that actually this can be taken as a profession, because before that I was only doing for fun. That it takes very it was I was very happy to make things representing something in the internet. Then I kept improving myself, and I can still remember till 2015, when I completed my graduation, I was not that good into basic software engineering principles, object oriented principle knowledge, or the solid principles. Then I found out that only making things doesn't matter. You need to apply those best practices if you want to develop something a scalable, efficient. Then I keep continuing learning in the internet to know these things, and I'm still learning, because sometimes these things make sense and sometimes it doesn't make sense. Sometimes I forget what actually happening, so I have to always keep learning these things from online resources or practicing it.
Yeah, makes sense. I mean, it's because I mean I had more or less the same path as you. Actually, I didn't go to school to learn those things, but basically I was doing that on my own. And that was exactly the same thing. Before moving to Berlin, to be honest, I had very basic understanding of development, or especially more technical development like we do every day. And actually I just learned by reading, by practicing with small projects. So it's what I want to share with the audience as well. It's just even if you don't know those things, it's pretty easy to get into that if you get very motivated and passionate about it.
Yeah, I agree with you. And I want to just mention one more thing, that there could be sometimes that at first glance you try to understand something, but it doesn't make sense. It happened with me lots of times. What you need to do is that you keep trying or go through that thing over and over again. And after maybe 5 times or 10 times, you'll understand that, yeah, it does make sense.
Yeah, for sure. For sure. That's something you learn with experience at one point.
Yeah.
Cool. So thank you very much again for your time. That was very great. I'll just share again your slide with your contacts. Feel free to share the links also in the group. Maybe some people might be interested to contact you and to get in touch with you.
Yeah, sure. I will maybe can share the code also in the GitHub and just share it, the link on the event page.
Yeah, that would be amazing. Thank you very much again. And yeah, stay safe. Have a nice weekend.
Yeah, you too. And yeah, maybe we can meet sometimes as we are in the Berlin.
Definitely.
Yeah.
Definitely. Maybe at a live event, when we will organize a live event again.
Yeah.
So thank you again. Ciao. Have a nice evening.
Yeah, you too. Thanks. Ciao.